Around the 1920s, physicists struggled to classify the behavior of quantum particles. Most believed that they would act solely like particles, but in 1924, Louis de Broglie was the first to propose that these subatomic particles may actually behave like waves. He rearranged the formula of a photon's momentum to isolate the wavelength, and this became known as the de Broglie wavelength. He stated that if a particle has its own wavelength, it must also experience the effects of interference like a wave does. In 1927, two physicists, Clinton Davison and Lester Germer, were able to prove this theory correct. They performed a double-slit experiment, which typically involves sending a medium through a screen with two slits, resulting in a pattern developing on a second screen placed across from the first. In their version of this double-slit experiment, they chose to direct a beam of electrons through a nickel crystal whose atoms were spaced in such a way to act as slits. It was expected that the beam would travel through the slits and form two vertical lines directly across from the slits in which it entered. However, the electrons instead formed a pattern which closely resembled the constructive and destructive interference of waves. The places where constructive interference occurred was where the most electrons gathered, forming a dark line, whereas the destructive interference was where the least electrons gathered, forming the faint lines in between the darker ones. Evidence of interference between these subatomic particles was significant because classical physics stated this feature was only possible for waves. It is also important to note that the pattern itself was formed by the collection of individual packets of the electron's energy. This is an example of classical particle behavior, where electrons carry their energy in discrete quantities. Because electrons display the behavior of both classical waves and particles, it was determined that quantum particles exhibited wave-particle duality. Finally, knowing the behavior of quantum particles has led to significant advancements in computers, the internet, and cell phones, and has even contributed to the invention of LEDs, PET scans, electron microscopes, and other technology.